Hello, everyone. I am the XAML Llama, also known as Michael Hawker, and we are here for the WinUI community call on September 11th, 2024. Glad you could all join us here today. Hopefully we're coming through loud and clear, and we've got a lot of great content for you today, so I'm super excited for you to be here with us to join us, and hope you enjoy all this content we put together for you. As an overview for the call, we have this introduction period, as always, of course, here with me. We will be going into the overview of all the features and things that we've shipped in 1.6 that just came out the other week, as well as a deep dive on the native AOT support. We have a guest speaker as well from Photos team, which we're happy to have join us here. And we have a section about tips and tricks for migrating from UWP to the Windows App SDK, as well as some info on the survey results from GitHub, if you saw that discussion there, and going into some plans and roadmap. We have some other special guests and other members from across our whole team with us here today. So we're really excited to have everyone here to present all this great content for you today. And as always, we will have a little bit of time at the end for discussion and Q&A. So if you have any questions, be sure to put those in the chat at that time, and we will try and get to those if we are able to. And if not, we'll try and make sure to follow up with anyone on GitHub afterwards, as per usual. So if you're new to the WinUI community call, we try and do these quarterly. And so the next one is going to be January 22nd, around our usual time here, 9 a.m. Pacific, which should be 1700 UTC, if I did my math right at that time. And again, post questions in the YouTube chat, and also feel free to connect with us on X, formerly known as Twitter, or GitHub. And also wanted to call out to be sure to follow the .NET Conf hashtag and look for that event on November 12th, 14th. We're going to be submitting content because the submissions and call for content closed this week. So we're hoping to have some content there as well. So just be on the lookout, and we'll keep folks updated as we learn more. If you're new to WinUI, it is the native UI platform for Windows 10 and 11, built for modern hardware and devices with the latest styling. You can use it to build .NET apps with C# or C++. Powers many experiences across Windows, such as the shell, different apps, as well as different platforms and like .NET MAUI and React Native for Windows when they're running on Windows, of course. And WinUI 3 is what we talk about here now today. It's the latest generation of this UX stack. It consolidates all these previous technologies and decouples the framework that ships as part of Windows and is shipped via the Windows App SDK, which provides, of course, WinUI, as I just mentioned, but also other APIs available to all Windows developers. And then WinUI 2 is the previous version of the framework. And so whenever we're talking about WinUI these days, it's WinUI 3. So hopefully that provides some context here. And so with that, I will bring in Duncan. And welcome, Duncan, to the call. How are you this morning?
I'm doing great. How are you?
I'm doing great. I'm good, great. Thanks for joining us to cover the features of 1.6 here. I'll leave you to it.
Yeah, thanks, Michael. And glad to see everyone. So we did just release 1.6 last week. Very excited about it. We had a lot of great features in there. And so I'll just go over it briefly. And we have gone over 1.6 a few times. So just in case you're new to 1.6, we did have a lot of great features. The banner feature we have is native AOT support. So we are going to get into that today with a nice deep dive, as well as decoupled WebView 2 versioning. And we're also going to get into that a little bit more detail right after this. So a couple other great features we have. We have new package deployment APIs. So if we have some new enhancements and updates for things like package removal, provisioning, detecting a pending registration. And another feature we have is improved tab view tear out, as you can see right here in the middle of our mosaic image. So if you've improved tab view tear out, essentially now with the new can tear out tabs mode, a user can drag a tab out and it'll instantly create a window, and you can also drag it to the side of the screen and snap it in just one smooth motion. And so we encourage you to take that for a spin. It doesn't use the drag and drop APIs and also supports running as administrator. And we have a couple other nice updates for controls like wrap mode for Pips Pager, and more customization for rating controls. We also did unseal items wrap grid, which is backwards compatible. And we have a couple other little great changes as well, including some new APIs to fill a gap from UWP, such as the color helper to display name API. And we also have a new class in MRT Core, the Microsoft Windows Globalization Application Languages class. So that gives you a new primary language override feature, so you can fine tune your app's display language. So yeah, 1.6 has a lot of great features in it, and we're excited to kind of dive deeper into them today. So I'll actually hand the mic over to Scott to get into more detail on the WebView 2 decoupling.
Thank you, Duncan. Yes, one of the main features that we added to Windows App SDK 1.6 was pulling the WebView 2 NuGet package out. Previously, we had embedded it. So we had taken the binaries, the metadata, and so forth from the WebView 2 NuGet package and included it as a component of WinApp SDK. And the problem with that was that the versioning, the updates, the bug fixes were in lockstep with Windows App SDK. So customers had to wait until a Windows App SDK update in order to receive those WebView 2 feature enhancements and bug fixes. So by decoupling it, now you can do an a la carte reference to the WebView 2 NuGet package to pick up those updates. That's an automatic thing, the NuGet reference to WebView 2. We've embedded that into the Windows App SDK NuGet package. So there should be no visible change to your projects. This should not be a breaking change. Instead of having those bits embedded in to the Windows App SDK package, now they are brought down through a NuGet package dependency of Windows App SDK. The second benefit here is that it resolves publish collisions that we were experiencing when you had another package that you were referencing that transitively referenced WebView 2. So I think entity framework, there were a number of issues that were opened on users who had an entity framework package reference, and they were using it in a Windows App SDK app. In that scenario, the WebView 2 binaries would collide at publish time, and there was no way to resolve that short of some MS build magic. And so this solves that problem as well. Now we have a single WebView 2 package reference, even if it comes in multiple times transitively, it doesn't matter, there's just one. So that's the big news on that. Now I will just point out a little note here at the bottom is that there is an issue with the WebView 2 package in terms of C# transitive dependencies, which is a regression with respect to the Windows App SDK 1.5 experience. That has been fixed. An update to the WebView 2 NuGet package will be going out shortly. I'm not exactly sure when, but real soon now. And when that happens, then you can take an update to the WebView 2 NuGet package. Again, you can add an explicit package reference, which will override the one that comes through Windows App SDK, and then you'll get that fix. And that's it for WebView 2. Michael, if we could advance to the next slide. Thank you. Now I'd like to pivot into talking about the native AOT support. What is native AOT? AOT stands for ahead of time compilation as opposed to just in time compilation. The difference being whether you are running against the CLR in your managed app at runtime and you are just in time converting that IL language into machine code optimized for your target machine. So ahead of time compilation trades that off and says, let's do this all ahead of time statically, and then we don't have to worry about this amortized cost of JITting this code. There's a particular benefit here in terms of startup, because that's where you tend to see this flood of, first of all, you're initializing the JIT, the CLR, and then you're doing all of this JITting of binaries. In the steady state, you tend not to see these kinds of perf differences, but it's startup where you really see it. And it also reduces the footprint, the memory footprint, the disk footprint, because you have smaller trimmed assemblies, binaries. You're really converting these. You're converting these managed assemblies into trimmed, optimized native binaries. This feature, AOT, really builds upon the publish trimmed and publish ready to run optimizations that preceded it. Publish ready to run was where you would look at the hot path, the hot start path, and then you would pre-JIT, you would AOT compile those hot paths into the target architectures that you were interested in. Native AOT fixes on a single architecture and does the entire set of binaries. It also trims them. So it's similar to the .NET Native optimization of UWP, XAML, C# apps. One of the advantages that native AOT has over .NET Native in UWP is the effort that the CLR team, the AOT team, has put into ensuring a debug experience that simulates what you would have at publish time. And this resolves a lot of the headaches that you would have had before with optimizations, where it wasn't until publish time that you would realize there were these subtle differences, very difficult to debug. So the way that AOT works is that at F5 debug time, you're still running against the CLR, but the CLR is running in an AOT simulation mode, which will alert you through diagnostics and errors and so forth to issues that you would encounter when you publish AOT. So it really helps you to nail down and resolve those issues before you get to publishing AOT. Once you've published as an AOT, now you've got a native app, and now you're doing native debugging. As it happens, you can still do source level debugging with your C#, even with that native. So again, the AOT team has put in tremendous effort here as they generate the simple PDBs that ensure that you can still do C# source level debugging with your native binaries, your AOT binaries. So it's a very good experience. Next slide, please, Michael. Okay, so we'll get into it a little bit here. This is a bit of a whirlwind overview tour of how the how of AOT. There's a lot more detail that we can get into here, but I just wanted to give sort of a survey here. So first we begin. How do we enable AOT in our project? The first thing we want to do is we want to set the Windows SDK package version property to a version of the OS that's .41 or better. This is going to determine the Windows SDK.NET C# WinRT projection version. The reason we have to specify this project property is because this is a C# WinRT projection that has AOT support in it, and until the .NET SDK is revved and picks this up, we have to provide this override. That is expected to land Patch Tuesday next month. So after the .NET SDK is revved next month and propagates out to machines, this isn't necessary. Both these asterisk points are only necessary until the .NET SDK is updated. The second point here that's needed is a C# WinRT 2.1.3, which is the very latest version. It published yesterday. Package reference, an explicit package reference. This is to pick up the source analyzer for AOT analysis of your code to ensure that it is AOT compatible. Again, with the update to the .NET SDK next month, that will include the source analyzer, even for applications that aren't producing C# WinRT projections, but just consuming them. But we still need the source analyzer there, so that'll happen automatically. The next thing is that for an app project, we add the publish AOT project property, MS build project property to your CS project file. For a lib project, you can add the is AOT compatible. So the difference here is that for a lib project, you are simply declaring that your code has been run through the Roslyn analyzers and is AOT safe and trim safe, and therefore a consuming app, if a consuming app wants to turn on publish AOT, the lib project is asserting that that's safe. Whereas for the app project, because this is a publish time operation, it's only at the app project that you really apply the AOT transformation. So that's why for an app project, you would specify publish AOT, which implies is AOT compatible for the source in the app project itself. The next step is that we mark our classes as partial. This is something of an implementation detail of how C# WinRT has implemented AOT support. The reason we mark our classes as partial is to permit C# WinRT to produce a side class, a partial class implementation that contains an attribute that's attached to it that enables the AOT and trim safe generation of vtable code to cross the ABI. So this all bubbles up as a detail to the developer to mark your classes as partial. The source analyzer for C# WinRT will alert you that you need to do this. So the experience, I think, is a good one for developers. You're led along the way. You're told what you need to do. The next steps that we do have to do with the AOT analyzers that the C# compiler ships with. And this is where you're getting into the actual differences between reflection-based AOT and trim unsafe code and statically typed alternatives. So whereas you might have had a foo.get type, which is a dynamic reflection-based method invocation, you would replace that with type of, so that you have static compile time type knowledge. If you're using serializers, very often you're going to run into issues with serialization, XML, JSON, and so forth. When you're using those, you want to use the updated alternatives that use static type information by way of something like a source generation context. If you're using DLL import for pinvoke, you want to use a library import instead, which is similarly going to be source generated rather than dynamic runtime code invocation. So all of these are, the basic idea here is you're getting rid of any sort of dynamic reflection-based code, which is not AOT compatible. These are all reflection-based approaches. Similarly, if you're doing anything that relies or makes assumptions about assembly identity, you want to change those. So a classic example that we made changes to in the WinUI gallery is where we needed to know where we were running from. Historically, you might use assembly get entry assembly location. You don't want to do that anymore because you can't make any assumptions about assembly identity. So instead, there's the new property app context-based directory static property, which will let you know where you're running from. And then the last point is simply, as you're proceeding through this, once you've added your publish AOT project property, you'll receive a whole bunch of warnings. And it's really important to take these warnings seriously. I can attest, I've been bit by this myself. I thought that I was following the right approach in suppressing a warning after thinking I had implemented it correctly. And Sergio kindly pointed out, no, that's actually not a safe approach. So the lesson learned here is to really avoid suppressing any AOT or trim related warnings and try to understand why those are being caused and remove that code and replace it with something that is inherently AOT and trim safe. All right, next slide, please. Okay, and then I just wanted to wrap up here with a few points here. There are some known issues and future enhancements that we intend to make here. The first point here, as I think some folks on the community call have noted, is that there is an outstanding issue in .NET in the runtime. It's an app hang, that's how it manifests, and it's due to an exception that happens on the .NET GC thread. So there's no known workaround, sadly, for this, and so we are awaiting a fix to the .NET runtime. It's in process. The fix has been made. It's just going through the pipeline. So until that is released, you may have a bad day in terms of your app hanging. I would not ship production code on this. It's certainly fine to start adopting it internally and experimenting, but until this particular bug is fixed, I wouldn't ship production code. Then there are a handful of AOT source analyzer gaps that we're still closing down on these. Manoda-san Wignarajan is the lead developer on the C# WinRT side for AOT support, and he's cranking out updates regularly. As I mentioned, 2.1.3 just released yesterday. There are a couple of edge cases that still require some workarounds. There's workaround code that we put in WinUI Gallery. I'm happy to share that if somebody wants to have a template. So things like .NET internal types like range iterator or read-only list, collections expressions where you've got, quote, bracket, some element bracket, and you pass that into some function that's expecting a collection. Those aren't supported yet. So there's still some edge cases here. Those are easy to work around. There's code that you can create to do that. And then finally, bindings. The XAML compiler, the intent as a future enhancement is to enlighten the XAML compiler to alert the developer when you are using a binding or some other kind of dynamic property path like display member path or something that acts like a binding, where you've got a dotted property path expression that's evaluated at runtime. The C# WinRT compiler now has an attribute that you can attach to the target of that property path, and this, since it could be nested, it's necessary to do this recursively, to attach this attribute. And essentially what you're doing is you are marking your types, say your view model types that you intend to bind to dynamically. You are marking them in such a way that the C# WinRT compiler can ensure that AOT and trim safe code is generated for those types. Next slide, please. We showed this slide at Build. This is an example app that we created, Contoso Camera, and you can see the difference with the animation that the startup time indeed is affected by this. The 8-time reduction in package size is with respect to a framework package deployed application, where most of the payload from the Windows App Runtime is provided by a framework package, so it's not included in the app package. So that's where you see the most significant gains. You could go from a 50 megabyte package to a 10 megabyte package by simply eliminating all of the self-contained .NET runtime and by trimming all of the projections. Next up here is just kind of a summary of some apps that we've converted to AOT to see differences. Now, these all happen to be self-contained, so you're not seeing as dramatic a reduction in package size, but nevertheless, it's still significant. So Contoso Camera here, from 65 to 25 megabytes self-contained. WinUI Gallery went from 75 to 41. Again, we're just completely jettisoning the .NET runtime, and then you can see some real dramatic gains on the time to the UI first frame, and lots of kudos to George Gao for pulling these numbers together. And at this point, I think we're at the end of the overview, and I'd like to hand off now to George to do a deeper dive on how we go about doing some of the perf measurements with respect to AOT benefits. George, take it away.
Thanks, Scott. Hi, everybody. I'm George, and I work on WinUI 3. And today I'm back to talk about perf, and especially in the context of AOT. Now, Scott showed some of the benefits that we saw from AOT, but the question I'd like to help you answer is, I've got a managed app. How much would my app benefit from AOT in terms of startup? Now, back in March, I showed our perf tools, which is the Windows Performance Analyzer and the Windows Performance Recorder. We're going to start with the recorder, because if you're talking about perf analysis, you always start with a trace. Make sure you have CPU usage and XAML activity checked. Then click Start, launch your app, and save the trace. I've already taken a trace before of our demo app, which is open in the Windows Performance Analyzer here. Also, from back in the March call, I showed the new XAML frame analysis table, which helps you zoom in to startup. And we load up the table and we see right here, it's already identified. Here's my process, here's startup. In here, you can see a region for initializing WinUI 3 and another region for the start of the frame. So the two things you want to do here is you want to identify the region that's startup, and then you want to see how much of that time went into running JIT, because that's all the time that's going to be saved when you do AOT. Normally, you just right click here, zoom in, but I'm going to do something extra today. I'm going to bring up the processes table right up here, and I'm going to zoom into the entire process. This here is the entire process lifetime for my demo app. I'm going to right click and zoom into here. I'm doing this because I'm interested in this time region. So this is WinUI initialization, but then this is the period of time after the process has started, but before it has initialized WinUI. So In particular, this is .NET initialization. And if we're talking AOT, this can see some optimizations too. So I'm going to select this WinUI region and drag the left margin over. So now I zoom into this area. I can close this table. I can get some real estate back. So the first thing is done. This is the startup time that I'm looking at from process start to the end of the first frame. And in terms of wall clock time, you can see it on the bottom right. I hope my image isn't here. If it is, then we can just dismiss it. But here I'm seeing 1.28 seconds from process launch to the end of the first frame. Now, the second thing you want to do is you want to check in this time window how much time went into running JIT. For that, we turn to the CPU usage sample table. When you take a trace with CPU usage checked, one of the things that it records are samples. Specifically, there's one sample taken every millisecond for your CPU cores. What code is it running? And this table merges all those samples together in stacks that are easy to view. So we can zoom in, or we can filter down to our demo app. So 1 sample per millisecond and 1,300 samples, but note that that does not equal 1.3 seconds. You'll see down here it's 1.28. So 2 reasons for that. One is, if I show thread IDs, these samples are taken on every thread for every core of your machine. And since I got a multi-core machine, some of these threads are running in parallel. So you might get multiple samples per millisecond. The other thing to note is that these samples are only generated if your process is running. If you're blocked on something, then wall clock time is going to tick, but you're not going to see any samples. If I select the UI thread here, which is the most expensive thread by far in the process, you'll see that it's running pretty steadily. There's a little bit like 30 milliseconds where it's switching in and out, but being blocked is generally not a concern here. So we filter to the UI thread. Now we're going to look in here for JIT, but before we do that, we need symbols. So trace, load symbols. This machine that I'm demoing on is not connected to any sort of Microsoft network, so I'm just using the publicly available Microsoft symbols. While it's loading, let me get some real estate back on the screen. Here you can sort by count, which puts the most expensive stuff at the top. I don't need that. I don't need that. Okay, symbols are done. Here we go. Now, you could dig in here for things that look like JIT. I am far from a .NET expert, so I spent some time ahead of time picking out these stacks. And one thing I noticed is a module called CLR JIT. CLR JIT. And this is just a Control F dialog you can use. Find next. So here we go. This is a method called CLR JIT native code. So I'm pretty sure this is a method responsible for running JIT. And this would go away once I convert to AOT. But the problem is this is just one sample. I'm sure these are all over the trace, and I want to find all of them. One way you could do is you could bring back the Control F dialog. You could type CLR JIT in here, and you could hit find all instead of find next. But there's a better way. There is a feature in WPA called view callers by function. And what that does is for a particular method, regardless of how we got to this call, it groups them all together, and it also merges the call stacks into this function. So let's give this a try. View callers by function. Here we go, it's done. So immediately we see there are 145 samples throughout the trace, and they are peppered throughout the place like you would expect. Also note that some of these samples do occur in the .NET initialization. So by including that, we've also seen savings there. Let's expand this and have a look. So this tree tells us that JIT native code is only ever called by a compile method throughout the trace. Everywhere it's called only by one method. That's only ever called by unsaved JIT function, and so on and so forth, down to JIT compile code. JIT compile code is called in 2 places. One is public versionable code is necessary. The other is prepare IL based code. And at this point, my .NET expertise has far run out, so I don't know what these things are doing. But going by this method name, JIT compile code, this is probably JIT specific. And I'm going to guess that this method does some overhead, maybe some prep work, maybe some cleanup, in addition to calling compile method. So we can actually get a better estimate of our savings. Let's copy this cell, and we'll reset this view with clear, and we'll Control F for in the stack column contains that new method I've identified. Find next. Right click. This time I'm going to use view callees by function instead of view callers. You can imagine what this does. Regardless of how we got to JIT compile code, start at JIT compile code and tell me everything that it calls. So in here, if I expand this tree, I've got the 145 samples in JIT native code that I saw before, but I've also got some other stuff. I've got unwind info. I've also got a couple of ETW costs. And I'm pretty sure these will all go away if I do AOT. So that adds up to about 200 samples, which leaves 927. So my estimate for this app is after I apply AOT, about 200 samples go away on the UI thread, about 200 milliseconds, which is about 20%. And it turns out we can check this because we did make an AOT version of this app. And the answer is 864. So there are about 60 more samples than we expected out of savings. So that's how you would measure this. You'd get a trace, make sure you have CPU usage and XAML activity, and then you use WPA to identify the startup window. From the start of the process to the end of the first XAML frame, you zoom into that window, and then you use the CPU usage sampled table to identify all the places that are running JIT. And that's how much you expect to save. In terms of wall clock, you can see on the bottom left, before we were at 1.28 seconds, and afterwards we were at slightly over a second. So also 20%. So that's all I have to present. We hope you give this a try, and we hope that AOT can produce meaningful benefits in your managed apps. Thanks, everybody. And now over to a special guest from the Photos team, Robson.
Thank you, Sergio. So I'm Robson. I work on the Photos app, the native app for Windows platform, Windows 10 and Windows 11. And I would like to just go over, introduce a little bit about our journey from UWP to WinUI migration, and talk a little bit about our work in progress on the native OT support. Can you go to the next slide? Yep. So Photos, we migrated the app back in May from UWP to WinUI 3 for Windows 11 users. And then we were looking for a few improvements in terms of decoupling the XAML layer from the OS, so we could get like features and fixes improvements from a library package. So that was like one of the main reasons for that. Also, we saw some great web view feature support on WinUI 3 and better performance and image quality for our editing component in Photos. And then we were also able to simplify the architecture overall. We wrote a blog post about that, our journey, like with challenges, gaps when you compare it with UWP, and we have that blog post on the Photos WinUI migration, if you guys would like to take a look at that. So the next slide, can you pass, Michael? Yeah. So one of the main gaps that we saw on Photos once we migrate to WinUI 3 is that the Photos gallery, which is written in C# and relies on .NET, had a slightly slower performance in startup, right? So for that case, we use Ready to Run, which improved quite a lot in our case, but we still see some JIT time, and then the startup time is still slightly slower than the UWP version. We also have the viewer stack on our app, but the viewer, when you go to the File Explorer and do a double click on a JPEG, that's pretty much native, so there's no performance downgrade. It's pretty fast. The main issue on our side is the Photos gallery, where you have all your photos, your collections. So we started working on the native OT, and it's still work in progress. We just got the numbers, targeting the latest 1.6 version, and then compared with Ready to Run version, which doubled the size of the managed binaries, we were able to reduce in 55% our MSIX package, which is great. And also for the first frame, thanks to George for helping get those numbers as well, we got a 50% faster to display the image. So like overall feedback from our side, from Photos, is just that as soon as you click on the app or open the app, you feel that it's very snappy and responsive, right? There's almost no delay to get the window up. And the rendering of UI element is smoother overall. It's really great. And then next, what we're looking for is get all these improved UX to customers, right? There's still a few things going on, like the GC, the garbage collection issue on .NET. We're waiting for that. That's something that we need. And then once we get that, we can publish this new version of Photos to customers. Also, we are looking with AOT now that we can move away from developing with C++ WinRT. We have been doing that a lot since C++ is faster, it doesn't rely on .NET. But then we want to move to XAML with C# instead of C++ WinRT. And also, like overall development experience with .NET, it's better. Like the IntelliSense, Visual Studio tooling, APIs. So everything is just better for compared with C++ WinRT. And then yeah, that's wrap. That just like overview of our journey on the WinUI 3, and then this is pretty much what we are expecting with the AOT for the last improvement. Now I'm just gonna hand it off to Sergio on the UWP support for .NET.
Hello. Hey everyone, thanks for joining us. I'm Sergio Perry, and today I wanted to talk to you about the new UWP support for .NET 9, which we just introduced. Next slide, please. So first, let me give you a little bit of an overview of what this is. So what we're doing is we're allowing you to modernize all of your UWP apps using the latest .NET, C#, and native AOT. So we're doing this for two main reasons. So on one hand, this provides you with a better migration path if you're moving from UWP to WinUI 3 and Windows App SDK. The reason for that is currently, especially if you have a large and complex app, it can be very difficult to move from UWP to WinUI 3. And that's because you basically have to move two different layers of things at the same time. So on one hand, you need to move all of the .NET code from .NET Native to the modern .NET. And that can be very tricky, especially if you have like a lot of manual COM and WinRT interop, or if your code base is not particularly trim and AOT safe, and you were relying on a lot of the heuristics that .NET Native had to try to kind of make things still work, but that native AOT doesn't have. And so there's a lot of work that can be required just to fix that alone. And then on top of that, you would also have to actually move all the app model from UWP to WinUI 3, and then move the entire UI stack from UWP XAML or System XAML to WinUI 3 XAML. And so this allows you to kind of get a checkpoint halfway through, and then basically, first, just focus on moving to modern.NET, getting your app working on native AOT, and getting to a point where the app is still on UWP, but is running on native AOT and still works. And then from there, you can just work on moving the UI stack on its own. So that's one of the first reason. That's the first reason. And the second one instead is that even if you plan on remaining on UWP for any reason, so for instance, perhaps your app is relying on some UWP-specific APIs that are not yet available on WinUI 3, or maybe you just don't have funding right now to justify a whole migration from UWP to WinUI 3, this still allows you to get benefits of all the recent improvements in the .NET ecosystem, all the new APIs, all the new C# features, and then moving to native AOT. And then in the future, you can still evaluate moving to WinUI 3. And so another thing that I want to call out is that all the improvements in the developer experience that's called out with native AOT still apply to all of this just as well. We're using the same exact tooling that managed WinUI 3 apps use. If you want to learn more about this, we have a blog that we just published today. You can check it out, and we have step-by-step instructions there on how you can try this out. Next slide, please. Right, so before I go, I want to also show you a couple of screenshots. So this first one shows you the new SDK-style CSproj file that's from a blank UWP XAML app using .NET 9. And so in particular here, you can see two things. The first one is that finally, we're also using the SDK-style CSproj. So you can see how the CSproj is super clean now, just 16 lines of code. So we no longer have the legacy MS-build old-style CSproj file listing just thousands of all the individual C# files, XAML files, and assets that you were using in your app. So this makes it much, much easier to just work on. And then you can also see how we enable native AOT by default, because that's the only supported configuration for publishing the Microsoft Store as well. This is meant to be a direct upgrade path from UWP using .NET Native. Next slide, please. And finally, here we're showing a UWP app using .NET 9 running and in the debugger. And I want to call out how you should be able to expect all the existing features and the debug experience from legacy UWP to work just the same here. So for instance, you can see how, of course, you have the usual .NET debugger with its own diagnostics tools. You have the XAML Live Preview. We have the XAML diagnostics with a live visual tree browser. We also have, of course, XAML IntelliSense autocomplete. We have both C# and XAML Hot Reload. And we also have a prototype of the XAML designer working, and we're looking into bringing it to Visual Studio very soon. So this is about all I had for you today. So please try it out if you're interested and send us feedback. We'd love to hear how your experience is with this. Thank you. And with that, I'll hand it back to Michael.
Thanks, Sergio. You summoned me.
Just assume.
We're going to bring in Hamant here to talk about the next section to give folks more tips on migrating from UWP to the Windows App SDK. Thanks for joining us for your announcement, Sergio. Congrats.
Thanks. Cheers.
All right, take it away, Hamant.
Everyone, hello. I'm Hemant, working out of IDC Hyderabad. Today, I'm going to talk about UWP to WinApp SDK migration tips. In this section, these tips are not so well documented so far, and the tips will be available in the official docs soon. There are many apps which are currently running on the UWP app model today. Please note that these apps will continue to work as they are, as the .NET support is also extended. But to leverage the latest features built for the native apps in Windows, WinUI SDK is the way forward. So this is our landing page of the migration doc. You can navigate to it using the AKMS URL. It contains multiple pages which cover overall strategy, features, and API parity between the UWP and Windows App SDK. Under the feature area section, you can find guidance on migrating specific features, APIs. For example, there are dedicated pages for windowing functionality, app lifecycle, MRT resources, etc. There are a few case studies as well to get you started in your migration journey. Before starting the migration of the app, knowing the features and API parity is also important. For example, UWP apps are use Windows UI's YAML namespace for building UI, and now it should be done through the alternates available in Microsoft UI's YAML namespace. That is a part of WinUI 3. So now I would like to talk about some of the common additional tips which would be helpful while the migrating the existing UWP app. First is window management. So by default, UWP apps get a core window created and managed by the OS. But in WinUI 3, app has to create their own window and manage its lifetime. So UWP app could get back the core window using get for current thread API to perform action and subscribe to events on it. But in the WinUI 3 application, the alternate that we suggest is to save the primary window of the app on the application level. Like in this example, we are saving it in the variable and fetch it back using the application.current API for the later use. As in this example, we are getting it back through the local typecasting and getting the object back. So if you are having multiple windows, consider creating a container like a list or a vector and manage the windows through that list. Also, see WinUI 3 Gallery app for advanced windowing management and how it can be achieved in a real-world application. Next is dispatch. So next slide, please. So yeah, next slide is dispatcher parity. So in WinUI, in UWP, we used to have core dispatcher to schedule work on the UI, and that cannot be done. In WinUI 3, we have an equivalent called dispatcher queue. But there is one fundamental difference between the core dispatcher and dispatcher queue is that the latter provides whether the attempt to queue the work is successful or not. And you cannot await directly as you can do it with the core dispatcher's run async method. If your app needs to wait on the UI thread work to be finished, then it can create an extension method. Like in this example, the app can create extension method like enqueue and inside this create a task completion source and return the underlying task to the caller. The caller can wait on this task. In the lambda function of the dispatcher, we can mark this task as a complete whenever the UI bound work is finished and let the caller know that the work is finished. And in the usage side, we just have to call await the extension method enqueue, and that's how we can achieve the synchronous parity between core dispatcher and dispatcher queue. So the next is keyboard events. Yeah. So in UWP, we had core window and there were key up, down, and character received events in the UWP core window. So similarly, what we can do is we can use key up, key down, character received events on UI element of on the root element of the XAML tree. So UWP also provide a get key state API, which basically tells you whether the key is pressed or not, a particular key is pressed or not. Replacement for this API is input keyboard source dot get key state for current thread. And there's another event related to keyboard management that is accelerator key activated on the core dispatcher. Apps when migrating now should be leveraging keyboard accelerators available on the UI element to create hotkey combination for the app, and that you can do in the XAML itself. So the next item on this list is display information API. Many apps use the display information Windows runtime API to find information and subscribe to changes related to display. When migrating apps should now should be using the display information API available under Microsoft Graphics.display namespace that is part of the Windows App SDK. In this table, we have a few API parities that are not directly available in the Windows App SDK, but we have the alternates that we suggest to use. Like for auto rotation preferences, we are suggesting to use set display auto rotation preferences native API. To get the next is like to get the DPI information and subscribe to changes to the DPI. You can use XAML routes rasterization scale, or you can subscribe to the changed event on the XAML route. A few other things are like current orientation that you can get through the DXGI output desk's rotation property if you are using the DirectX rendering. And there is a static event display contents invalidated. If you are using this event to track DirectX device availability, we suggest instead you should be using register device removal event. That is also a DirectX API. Next is WinMD references. So this section applies to .NET apps specifically. So if UWP app used to could directly add references to Windows metadata to consume the native code. If while migrating, if you see this compilation error when you are migrating to WinUI 3 and Windows App SDK, that the component cannot be referenced. Referencing a Windows metadata component directly when targeting .NET 5 or higher is not supported. So the resolution of this error is like you should be removing the older references to Windows SDK contracts package and specify the Windows API target framework version property from project file. And the second thing that you have to do is if you are referencing any Windows runtime native component, you should be creating a C# projection of that component using CSWinRT tool, and then you can consume the C# projections in your latest WinUI 3 app. So this is it from my side. And now I'll hand over to Rinku to share results on the GitHub survey.
Yeah, thank you, Hemant. Hi everyone, I'm Rinku Stephen. I'm the product manager for WinUI developer experience on Visual Studio. So Michael, can we move to the next slide? Yes. So for the first time, we floated a survey asking overall, how do you rate your experience on WinUI, and we also gave an optional field for adding comments. This survey was live over 30 days in the month of July, and we had around 58 developers participate. We received 38 comments, which were bucketed into 5 feedback themes. The DevStat score based on the ratings have come to 50, which is very moderately satisfied with the experience. So based on the feedback themes, we've identified these 5 feedback areas for us to work on. One is there's a clear need for WinUI 3 development, improved documentation and addressing the tooling deficiencies. Next is there's a call for increased engagement, that is transparent bug fixes and more responsive handling of bug reports. There is a request for open source contribution and community involvement in WinUI, and a request for WinUI 3 to achieve feature parity with other frameworks, and finally need for better improvement in management and community engagement. Now, keeping these things in mind, we've amped up our community engagement. We are working on improving our documentation. On top of that, we're also working on improving the tooling experience. Michael, can we move to the next slide? So with that, here are some steps that we're taking to improve the tooling experience. So the first thing that we're working on is the designer. We're in the very early stage of exploring how can we integrate a designer into your development experience on Visual Studio for WinUI. Next thing that we're working on is the WinUI 3 Apex bundles generation. So basically today, Visual Studio doesn't generate Apex bundles for WinUI. So we're introducing this new feature, where it will be generated for you. Right. Another cool feature which is actually now available in preview is searching for WinUI components in Visual Studio installer, which is a common feedback that we've heard from especially new developers that hey, I'm finding it difficult to set up the workload for WinUI. So we try to fix this by introducing option to search for the WinUI components now in VS installer. We have this available in preview. And we've also working on fixing the IntelliSense experience. The first step towards that is to ensure that unsupported values don't appear in your IntelliSense suggestions, right? So these are some of the tooling improvements that we are looking into based on the survey feedback. Michael, over to the next slide. Yeah, so this is just a snapshot of the search that option that we've introduced for WinUI components in VS Installer. It is currently available in Visual Studio 17.12 preview 1. Do try it out and share your feedback with us. You can just search for WinUI as the keyword and you'll see the list of components there. Yeah. So with that, that's the update from my end on the survey. Over to you, Michael.
Thanks so much, Rinko. Appreciate your insights into the survey. And I know you gave me a link to share as well. And so let me actually just take a second to grab that, if I can find it again. In case anyone missed the GitHub survey, then they can provide any information about tooling from the GitHub discussion. That's the link didn't copy, right? Me copy the link and put that in there. All right, let's see if that worked. Okay, great. Thank you so much, Rinko, for joining us. And next, we have a little bit of information about what's coming next. We're currently in the early stage of planning 1.7 after our 1.6 release here. The top of mind things that the team is looking to investigate are convenience APIs for XAML window, addressing the title bar, preview feedback, and we have some process that we want to share soon. I'm not sure it's supposed to be, I think, going up soon, but we'll basically add info and detail on there at that discussion link I have below for these plans. Continuing the work that we mentioned that was coming, getting started in the 1.6 timeframe around table view and inking, cross-process islands. As Rinku just mentioned, some of the tooling improvements around the WinUI 3 designer, web authentication, camera capture, and then just in general quality and other experience and issues and more. So if you want to comment on these and look at some of the other things that are on the top of our mind for the team to look at, join our discussion at aka.ms/WinAppSDK/plans and be able to join the discussion there and help us prioritize and see what's at the top of your minds as well. And with that, I wanted to share some of our upcoming dates. As I mentioned, .NET Conf is November 12th and 14th. And so that's a free virtual event you can join. We're still putting together and submitting comments, content for that. And so we'll see and share more details about that event and what content you'll have to look forward to as we learn more from the organizers there. Microsoft Ignite is also coming up in Chicago the week after. It's available free online as well if you want to attend digitally and check out all the streams and sessions from there. And our next community call, as I mentioned at the start of the call, is January 22nd at our usual time here on YouTube. So we will hope you join us there and see what the latest information and features we're working on at that time are. And from there, we're going to go into Q&A. We a little short on time since we had a lot of content for you today. But I'm going to start by pulling in Sergio here to talk a little bit more about his announcement on UWP support for .NET 9. Welcome back, Sergio.
Thank you. Love this question. The answer is right now. So that's for supporting modern.NET. And as for WinUI 2 projections for CS-WinRT, we are currently looking into that. So one of the blockers was WinUI 2 has a dependency on WebView 2, and we just did the work to get WebView 2 to also support both UWP on .NET 9 and AOT projections. So as soon as that's available in preview, which should be very soon, then we'll also look into publishing a new preview of WinUI 2 with UWP projections for .NET 9.
Great. And how should people look at this new announcement about being able to use the modern .NET 9 on UWP? I think you mentioned this out in your blog a little bit about how this is framing the goals of the project. You mind just reiterating those here for people on the call?
Yep, absolutely. So as I mentioned, there's basically two reasons for this effort, and we're not trying to get new people to create new UWP apps right now. This is really meant for either cases where you want to migrate from UWP to WinUI 3, but you have a very complex and large app, and so you feel like doing the whole thing as a single step might be too complicated. And so this allows you to just split the work into 2 checkpoints. So for instance, I mentioned that in the blog post too, this is what we're currently doing in the Microsoft Store. So we're currently working to migrate the Microsoft Store from UWP with .NET Native to UWP with .NET 9 and native AOT. And then from there, we can investigate and move and do the work to actually move to WinUI 3. The other situation is if you're already on UWP, like if you are not planning to move to WinUI 3 right now for whatever reason, like maybe you can't because you're missing some APIs, or maybe you just don't have the time or the budget to do all that work right now, we still want you to be able to leverage all the improvements of the latest .NET ecosystem. And it's something that's just better for everyone. Like the more people get to latest .NET, the better, regardless of what UI framework they're using. Might be WinForms, WPF, UWP, WinUI 3, it doesn't matter. We just want everyone to be on latest .NET, especially when a lot of the tooling that's shared now between UWP and WinUpSDK is the same. So like improvements, for instance, like CS-WinRT is exactly the same. The single project MSAX tooling is exactly the same. All the projections for all the WinRT components, like for instance, Win2D is the same infrastructure. So this also allows us to get more feedbacks on the same tooling, which then in turn benefits everyone. So it's really just a win-win for everyone and the whole Windows ecosystem.
Awesome. Yeah, thanks for that clarification. That's really, really helpful to know. Like, yeah, this is really about a journey for developers to help modernize their applications in different ways, or as a stepping stone towards WinUI 3. So it's really, really great. I actually have another question while you're here too. Someone asked in chat about if SQLite was AOT ready. So just talking about the native AOT features that shipped with the Windows App SDK 1.6. And I think you had some insight here, depending on what version of SQLite it was.
So there's 2 different versions that I know of SQLite. So one is the EF Core SQLite provider. I'm not super familiar with that one. If you're talking about the SQLite Net, that other library, that one, I'm also interested in that because I'm also using that in a couple of my apps. So that one is currently, you're right, it's not AOT compatible, but I did a PR for it to add AOT support, and it's currently just waiting for reviews and approval. So we're hoping to get that available soon. So if you're interested, you should be able to find the PR if you go to the repo on GitHub, and you should be able to follow the progress there.
Great, thanks, Sergio. Appreciate that. So I think we have time for one more question. I think there is some other ones here, and I'm not entirely sure who was supposed to answer this one. I don't know if this was a you, Sergio, question. I'll add Scott and George and Duncan on here as well in case they know about D2D and Win2D and DWrite Core.
What's the specific question with respect to those packages?
Sorry, the question was my other intention to make it possible to render using D2D or Win2D with DWrite Core, I believe. So I think the general question when for a lot of questions too is it's usually best to create a discussion on GitHub, create or an issue, give us some more detail and specifics about what your scenario is, what you're trying to do, what libraries you're trying to integrate with, and that's a great way to help us engage with the team and get that context so that we can follow up with more details later. So I'm sorry, I thought we had an answer for this one.
If you can add something to this, Michael. I'm not super familiar with DWrite Core myself, but if you're talking about D2D and Win2D, that it's already possible to draw content both on UWP and WinUI 3, of course, using both D2D or Win2D. In fact, we just shipped a new version of D2D just a couple of weeks ago, which also has the WinUpSDK 1.6 preview and AOT projections. So that should all work just fine. If you had any specific issue, yes, please just post it on GitHub and ping us, and we're happy to take a look and help.
Great, and that might be the context we're looking for here too, right? And maybe it just means that we're missing a sample or some documentation, or it's harder to find. So yeah, if there's anything like that, if you're finding issues with the documentation or finding something hard to understand, there's the feedback up and down on the docs that goes right to the doc team, or you can propose changes or edits to the docs as well in certain sections. So there's a lot of great info there. for developers, and just give us info. You know, there's a lot of it. It takes us a while to process and get to sometimes, but we're always listening and paying attention and looking at seeing what's going on. And as you've seen with native AOT and the 1.6 release, there's a lot of stuff going on under the hood to make sure that developers have the best performance and experiences in their applications. And we're just continuing that trend release to release. So folks are asking for more Q&A time. We are at our normal end here, so maybe we can take one more question to see. Let's see what's going on here. So I know we've answered the SQLite one. I think this ties into the last discussion too here from Arthur about if XAML 2009 will be supported in near future releases for like type arguments. I know one of the people who was going to answer the question was unfortunately unable to make the end of the call here. They had something come up at the last minute. But I think in general, you know, these are always kind of things that we're looking at, and how do we prioritize and look at issues. And I think a great way to do that is if you see issues in the GitHub repo on the Windows App SDK repo or the WinUI repo, just give them the GitHub thumbs up on the original poster there. And then that lets our team here sort by the number of thumbs up. You know, it's pretty common practice on GitHub. And so then that way we can, you know, look at these types of issues, compare them to other issues within the repos, see which ones are getting more traction or more votes from different developers, so that we can kind of use that as that gauge of saying, okay, well, this one has 200 thumbs up from developers and this one has 50. So we're going to look at that one with 200 upvotes first. So that's something we're going to be trying to do a better job at looking at it and bubbling up as we move forward. So unfortunately, I think we're going to have to wrap up here. We're running really, really long compared to normal. But if we didn't get to your question, we apologize. But please, you know, follow up on the community call, GitHub discussion there as well, and we will look to get that to you. You know, get back to you and reply to any questions we see, or follow up on the questions that were asked before the call as best as we can in the near future here. And be sure, as always, to make sure to fill out the survey here from the aka.ms/winui/survey link. The survey about the call here really gives us feedback about how valuable these are to you, and what sections and information you type like, and helps us shape the future calls and help us make sure we do these as often as we can. So please be sure to fill out that link. I'll post it in the chat here, and I think that's going to be it for today. So appreciate everyone here for joining me on the call and answering our questions and providing all this great information to us. And we'll see you next time. So thank you again, everyone. We appreciate your time.